Here's problem 1118. 5 objects of mass m move at velocity v at a distance r from an axis of rotation perpendicular to the page through point A as shown. The one that has zero angular momentum about that axis is, so we're talking about a mass moving with velocity v at a distance r from an axis. Angular momentum by definition in this case is equal to mvr, at least in magnitude. So if we were to look at all these cases separately, r being the shortest distance to the line of action of the velocity. So if we look at the first one, we have a velocity direction going like this. Our r is this distance here from the axis of rotation. So there will be a certain angular momentum associated with that r times the mass m times the velocity v going like this. Sounds good? Same thing with b. There will be a certain amount of angular momentum associated with this v, this mass m here, and this r to that point. One of these will be negative, this one will be positive, and part A will be a negative angular momentum, but there'll be finite value. Alright, so if we look at C, very similar thing. We have a velocity going this way, we have a mass m, and we have a r, which is this distance right there. Alright, now if we look at D, here's our line of action. We have no r is equal to 0. So the angular momentum of D is actually going to be equal to 0. That will give us 0 angular momentum because we have no moment arm for the velocity. There is no perpendicular distance to the line of action. The line of action goes through our axis A. So that angular momentum is 0. Let's look at E just for comparison. Here's our velocity. Here's our line of action. And there is a distance, very short, but there is a distance r from the axis to that line of action. And hence, that has a finite value of angular momentum. So the only one that has 0 angular momentum is answer D. So that's our answer, D.